Hi everyone. I'm going to talk about BC6H again. This right here is called BC6H. It is the bane of my existence. Anyway, I've set up some code that basically takes resources Shanghai.jpg, which is a lovely picture of Shanghai. In fact, I think I can open it because it turns out the Visual Studio has a really cool image viewer that I didn't know existed. Here you go. It is a quite a large image, but I just needed something that was very varied and specifically that I hadn't tried to use before. Because I've got noise here, rainbow here, and I just needed an image that was none of those and was nothing from Compressinator, because Compressinator comes with these images of this video game lady and this Ruby. There's also balls.xr, but I don't think that'll open here. You just don't open that one. It's like a set of transparent balls being rendered in like a 3D renderer, 3D rendering test. Anyway, the point is, I wanted to test it with a brand new image from a brand new source, so Shanghai. We go to file I'm in now. This is the method that's going to be called. We basically load the image. We assert that it loaded okay, and we assert that it is the expected format. The reason we did this is because sometimes images lie. So that's there. We also pipe in the quality and threads, and so you can see I'm just trying to run a single-threaded BC6H operation. Now, very important to note here is that I am using Comp process texture. Frux does not use Comp process texture inside of Resonite. This is the difference that I have been searching for like 12 plus hours now. Anyway, let me show you what happens. So if we run compressinator samples, what you're going to see is that everything launches up, and then some debug code that I left in and have been trying to remove for about 4 builds, but still have not managed to build, is there. What this is basically doing is it's logging line numbers, and that's because it was hard 12 hours ago for me to understand where in the native code things were going wrong. However, turns out that through some wizardry involving Google, a lovely YouTube channel I'll put in the comments, and my own sheer determination to fix this, I have found out how to get into the native code. So here we are actually inside the native code, and it's saying hey, access violation, reading location, blah, blah, blah. And I'm like, well, clearly this has to be a bug of BC6H. Let's go ahead and take a look inside what's going on. So this bug actually occurred in here, and it's going to say it's different, and that's because I've already started editing it. And so what's going on here is a lot of stuff, a lot of maths, but here, and more importantly, is a p source pixels value. Now, this looks like an array, but it's important to note that this is offset and that we have a pointer here. So what's actually happened here is, and this is one of the reasons why this is a native library as well, the native library has basically just sent this function a pointer and some data and said, deal with it, right? And it's slurping along raw memory inside the computer, picking up pixel data from the image over and over again. But it's not an array, it's a pointer, and it's a pointer to half. Now, half is a numeric type that just so happens to be made by Industrial Light and Magic. Yes, that Industrial Light and Magic. But it's basically a 16-bit floating point number. So what's happening here is that when we access this pointer at this offset here, the computer, I don't really know what part of the computer, I don't care, to be honest, it goes hey, that doesn't exist. That memory just it isn't there, it isn't yours, you shouldn't access it. It doesn't make sense for you to access it. I thought it was an array, so I stuck in a null check here. Unfortunately, that doesn't work. That's just checking if the retrieved number is 0, because this particular null means 0. It's C++, right? So I'm debugging around, and I'm hey, what's going on here? Maybe we're reaching too many pixels. So this source offset, very large number. It's okay, well, where are we in the image? We are in we're in block 3. says one of these I can actually mouse over and see. Just we're somewhere over the image, right? So what it's basically saying here is the image data doesn't match what we would expect the image data to have. What's going on here? So I spend forever researching this, and I mean literally forever. It turns out it's just another typo. So I'm going to show you where the bug is. What I started doing here was I started looking at block X, block Y, etc., and figuring out like how are these defined? What's going on with these? How are they defined? And they're defined from the properties block width and block height. I shouldn't have actually halted that. I have to start it up again. Sorry. So there we go. It's gonna do a bunch of stuff. What time is it? It's not actually that late. I'm good. I mean, it's very late, but not like that late. I was up till like 7 yesterday. I gotta do it again to capture the location. There we go. If we bubble up the hierarchy, what we'll see eventually is that we get to compress texture, which is here. This function is what Frux uses in Resonite to do the BC6H conversion. So anything below here, and I need to remove this printf, but anything below here, Frux engine is using fine, and there's no problem. And that should have been my first hint that it's above there. So what we do is we go for process texture. So this is where compressed texture is being sent. And here you can see my lovely print lines that, once again, I need to remove, but whatever. And I'm like, oh, what's going on here? And there's a lot of stuff going on here. It's very difficult to read. I scroll up here and there's just like a block of data, and I'm like, oh, this will be fine. But it's not. There's a subtle bug in here. So this is the source texture. And the source texture's block width is 0 because the source texture is not block compressed. That's why we're in Compressinator. We're block compressing. So we've got block width 0, block height 0, block depth 0. It is not a blocked format. So now we need to go down to destination texture, and you'll see that destination texture, which is a block format, BC6H, gets its block width and block height from source bitmap, not destination bitmap, because destination bitmap gets its block widths set appropriately up here. So you can see up here, dest bitmap m block width equals 4, which we would expect 4 by 4. That's what block compression is. But then down here, destination texture, block width 0, block height 0. Probably get block depth set there as well. I don't know if that's actually calculated. Maybe it isn't. Block depth 1. Yeah, I might just double check that that's set as well, because like that isn't set here. So the whole problem all day that I've been trying to work on has been just like typos here. Also, I think like I haven't done this, but like it all logically makes sense. Anyway, I'll see you tomorrow.